Good morning. So, in continuation of our earlier class for the carbonic qualitative test, today we are going to see the two tests for the confirmation of aldehydes and ketones. So, that today, last time we have seen that 240 NP test, which is a general test to identify the carbonyl functional group, and second test we have seen the chromic acid test, which is the test to identify the aldehyde in the mixture. Now today we will see the tolerance test, which is used to identify the presence of aldehyde, whereas the second iodoform test is the confirmation of methyl ketones, or we can say carbonyl ketones compounds. So now first test, the tolerance test. It is test for aldehyde. So we know that aldehydes are also oxidized by tolerance reagents, a substance that contains silver nitrate, silver ammonia. So when silver ion is simultaneously reduced to metallic ions. So in this reaction, what is happening when aldehydes are reacted with tolerance reagents? It will undergo oxidation to corresponding ammonium carboxylate, carboxylic acid, and silver ion, and water and ammonia. So silver ion is a weak oxidizing agent. Aldehydes are very easily oxidized and are essentially unique in being able to reduce silver ion to silver metals. So what happened in this test? What happened? The total test tube will become silvery color, mirror color. That's why it is called mirror test. Silver mirror test also it is been called. Now, there is one example or one limitations of this reaction, failing test or this test, that benzaldehydes will not undergo the failing test or tolerance test. What is the reason? So the rate limiting step in these reactions, if you see the failing test reaction with aldehyde, is the formation of the corresponding enolate. So in this reaction, what happened? We need the aldehyde with alpha hydrogen. So in the case of phenoldehyde and benzaldehyde, there is no alpha hydrogen is present. There is no hydrogen present to the carbon which is attached to the carbonyl group, which is called alpha carbon. So there is no alpha hydrogen present on the alpha carbon in the case of benzaldehyde as well as phenoldehyde. So that's why there is no reaction will take place, or they will not give the failing test or tolerance test. So these hydrogen, alpha hydrogen, will require to initiate the reaction to form the enolate. Now, if you see the subsequent reaction of the enolate with copper to proceed through a single electron transfer reaction, when aldehyde that lack alpha hydrogen such as benzaldehyde or phenoldehyde cannot form an enolate and thus do not give a positive failing test results under usual condition. Similarly, benzaldehyde don't have only have the carbonyl group which is directly attached to the carbon ring, electron rich ring. That's why it is not giving the test. Due to this, the polarity of the carbon hydrogen bond in the carbonyl group is reduced. Thus, the carbon hydrogen bond now has a higher electron density. So that's why it will not react. Therefore, the CH bond becomes stronger and less polar bond. Therefore, it will not undergo the reaction. Therefore, thus, failing solution, comparatively weak oxidizing agent and tolerance reagents, cannot oxidize benzaldehyde and aromatic aldehyde. However, failing solution can oxidize to an aliphatic aldehyde. So now, to identify between aromatic and aliphatic aldehyde, failing test is very important. And the second test, which is used to identify the ketones in a mixture, is a iodoform test for methyl ketones. So any carbonyl compound which has methyl group will undergo this iodoform test. So in this reaction, the ketones will react with iodine in the presence of base to form carboxylic acid salts and meet iodoform as a product. The formation of iodoform is confirmed when the ketone is present with methyl group. So methyl ketone but not other ketones are oxidized by iodine in aqueous sodium hydroxide solution. The ketone is oxidized to a carboxylic acid, yellow iodoform also formed. it is a yellow iodoform that is indication of a positive test. Acetaldehyde, but not other aldehyde, gives this test owing to its structural similarity to methyl ketones. So only acetaldehyde, because it has one side methyl group, CH3 group, that's why it is giving the iodoform and it is a positive test. So there is some limitation is there. It is also true that ethanol oxidized to acetaldehyde and secondary alcohol that can be oxidized to methyl ketone give this test. So the limitation of this iodoform test is that when ethanol or any secondary alcohol which convert to methyl ketones via oxidation will also give this test. So there is a ambiguity. So what is happening in this reaction? This methyl ketone will react with iodine, sodium hydroxide. It is oxidation reaction. So sodium iodide will form and then oxidation, sodium carboxylate will react. And so iodoform solid yellow color will form. So this formation of this iodoform is indication of presence of carbonyl group. Now what is the actual procedure? So procedure is simple. When the substance to be tested in water soluble, take 4 drops of liquid or an estimated 50 ml of solid in 2 ml of water in a lactate tube. In that 2 ml of sodium, 3 molar sodium hydroxide solution has been added and then shake well and then add iodine solution, 3 ml of iodine solution. Then close the test tube with a stopper and shake vigorously. A positive test will result in the formation of brown color of the reagent disappearing and the yellow iodoform solid will form. So the disappearance of the brown color of iodine to formation of yellow color solid is indication of the reaction, oxidation and confirmation of this test. If the substance to be tested is insoluble in water, if any ketone is insoluble in water, then dissolve it in the 1,2-dimethoxyethene can be dissolved and test can be done. So mechanism we can see in this case what happened is ketone which is having the alpha hydrogen. So base will take this proton and will give you this enolate. This enolate will react with iodine and iodination take place, addition reaction, and then this iodination will take place 3 times because 3 hydrogens are there. So 3 iodine will take substituted at here, and then after that under base catalysis condition this ketone is converted into carboxylic acid and this methyl group will break. So we will get a triiodomethane. So it is a reaction, multi-step reaction with 3 times iodination take place, 3 times enolate will form, and then oxidative cleavage take place between this carbonyl carbon or this triiodocarbon, and then finally we will get a triiodomethane and acid. Now there is a question arises, does acetic acid gives a positive result with the iodoform test? So we know that acetic acid also contains the CH3 CO group. So theoretically it should give a positive result in the iodoform test. Yellow precipitate should form. But practically acetic acid will not give a iodoform test because it is not a carbonyl group. It is a acid group and that acid group delocalizes and does not respond to the iodine test. So acetic acid although has CH3 CO group which is required for the iodoform test, but it is a containing the in the form of carboxylic acid form. So with this we have completed the quantitative test of carbonyl compounds, in which we have seen how the carbonyl compounds generally identified in a mixture by using 2,4-DNP test, where we have identified the ketone and aldehyde functionality. Then we have seen how this aldehyde and ketone can be separated, by how aldehyde can be tested by chromic acid with Tollen's test, and then how ketones can be tested or identified by using iodoform test. Thank you very much. We will see in the next class.